Hey there, I'm Rachel.
And my name's Dawson. And that's our friend Angie.
In each episode, we will explore the world of STEM with you.
Whether it's learning how a computer understands your keyboard inputs,
or determining how shade helps you feel cooler,
we're here to help break down these concepts so that everyone can understand them.
And together, we make STEM happen.
Today, we're going to do science with chocolate.
Chocolate? Okay, I'm okay with this plan. What are we doing with it?
So, we are going to measure the speed of light.
Okay, you lost me. How does chocolate have to do with speed of light?
That's a good question. This is kind of a complicated question. So we're going to put the chocolate bar into the microwave and we're going to get 2 melty points.
Okay. I'm not quite following. What do the melty points have to do with speed of light?
Okay, so light goes in a wave. And as we know, a wave has a high point and a low point. Mm-hmm. So with the chocolate bar, we're going to have the wave come up and go through, and we'll get a melty point, and then go under and back up, and we'll get a melty point, and then it'll go back up out of there like that.
Okay, so we're looking at the wave of the light.
Yes.
But how do we get the speed?
That is also a good question. So the speed of light is equal to the frequency times the wavelength. And with the 2 melty points, we can measure the wavelength.
Okay, so how do we get the frequency?
That's a good question too. We'll need a microwave.
Whoa, okay. This is pretty cool magic. Okay, so now that we have the microwave, how do we find the frequency?
Well, all of your microwaves should have a sticker that gives you the number for what the frequency is.
Okay.
Then, here's the list of all the things you'll need to do this experiment. So the first thing that you're going to need to do is open your microwave and take out the turntable and the wheelie bit, if you have a wheelie bit.
Ours has a wheelie bit.
Okay. Our microwave also has a little turning piece in the middle. Some microwaves have them and some don't. So the next thing that you'll need to do is you'll need to get 1 or 2 plates, depending on if you have the turning bit in the middle. If you have the turning bit in the middle, then you will take one of the plates, flip it over, and cover that. If you don't, then you don't need that extra plate. Then you will take your plate that you do have, put it into the center of the microwave. Then you'll unwrap your chocolate, and you won't take a bite out of it.
Dang it.
And you will put that chocolate on the plate into the microwave.
Okay.
And then we heat the chocolate up for 20 seconds.
That sounds really easy.
It is really easy.
Let's get started.
So we just melted our chocolate and we took it out of the microwave. And so now we need to identify the 2 melty spots and then measure between them.
Let's go.
So we can see that we've got kind of a melty bit over here, and we definitely have a large melty bit over here. So with the toothpick, we're going to see the 2 spots, that kind of edges of where they melted, and then we're going to measure it.
Okay.
So we can kind of see that this is the edge of the melty bit here, and then over here, this looks like it's the edge of the melty bit.
Oh, yep.
Okay. So I'm going to put my toothpick down.
Okay.
And now we're going to measure it. And you can help me out by measuring it.
Here, come a little closer.
All right, what do you see?
I see 6 centimeters.
All right, I see 6 centimeters too. All right, let's go with that.
Okay, let's write that down.
All right, we've written down a really important number. It's 6 centimeters. And that's going to be the distance between the 2 spots. But it is not the wavelength. The wavelength has a really fancy symbol. It's called lambda. And it's actually twice this number. So 2 times 6 centimeters equals 12 centimeters.
I don't quite think I understand why that's twice.
Yeah, that's a good point. Maybe we can turn it over to Angie, and Angie can teach us.
Let's learn about waves. Let me draw a wave for you. Perfect. Now that we have a wave, we can learn about the parts of a wave. The top of the wave is called the crest, and the bottom of the wave is called the trough. If we measure from crest to crest, or trough to trough, that's one wavelength, also known as lambda. Now for our experiment, this is where the chocolate bar would be. See how if we measured from melty spot to melty spot, it would only be half a wavelength? That's why we have to multiply our measurement by 2 to get the true wavelength of 12.
Well, thanks, Angie. That was really helpful. So now we know what the wavelength is equal to 12 centimeters. We might be thinking, centimeters isn't something that we're completely familiar with, and that's okay. So here in the United States, we tend to use feet and inches, where most of the rest of the world uses centimeters and meters. So that's what we will be using for the rest of this math. We also need to do something that's a little bit tricky. We need to take these 12 centimeters, the wavelength being 12 centimeters, and change it into meters. It's pretty easy. We know that there are 100 centimeters in 1 meter, making the 12 centimeters equal to 0.12 meters.
Okay, so the next thing would be to calculate frequency?
Sure. It was pretty easy to calculate the frequency, though, because the frequency was listed on the microwave, and that was 2450 megahertz.
Now, megahertz I've never heard of before.
Yeah, that one might be a little bit unfamiliar to everyone. So the mega in front of the hertz means that we have a lot of extra zeros on this number. So let's write it out. Frequency is equal to 2450, 1, 2, 3, 4, 5, 6 zeros in hertz. Hertz is also another unit that we are unfamiliar with, but it means 1 over second. So that's pretty easy.
Okay, so it looks like we have everything to calculate speed of light. Do we want to start calculating it?
Yeah, so what we need to do is multiply this big number times 0.12 meters. And I'm going to write it out. Do you mind typing it on the calculator?
I can do that. Okay, I have 294,000,000.
Okay, and that's meters over seconds. So this is what we calculated as the speed of light with our chocolate bar in the microwave.
Okay, so how'd we do?
We did pretty good. I've got the real number right here.
You know, we're pretty close. I'm 294 and you're 299.
Yeah.
So what is this number again?
So that's a good question. To recap, that is the speed of light that we calculated by taking a chocolate bar, putting it in the microwave, melting 2 spots, and then measuring the distance between the 2.
Yep.
Then we took that number and we multiplied it by the frequency that we got from the microwave. And once we multiplied those 2 together, then we calculated the speed of light.
Okay, but we're not all the way there.
No, this is an experiment still, and so we actually could only get up to 98% accuracy with this method.
So I wonder what the number would be if we used different kinds of chocolate.
Thanks for doing science with us.
What chocolate did you melt? And how close did you get to the real value of speed of light?
Sadly, I won't be able to make it to the next episode.
But we will have a guest star to make up for it.
Until then,
See you next time.
Angie. We're gonna learn it from Angie. We're gonna learn it from Angie.
This is called lambda. No, it's not a lamb.
We're gonna learn it from
Duh.
Angie. We're gonna learn it from Angie. She's a robot from Sweet. We're gonna learn it from Angie. We're gonna learn it from Angie. We're gonna learn it from Angie. She's a robot from Sweet.
Day one.
We're gonna learn it from Angie.
Haven't seen
We're gonna
light
learn it from Angie.
3 days.
We're gonna learn it from Angie. She's a robot from Sweet. We're gonna learn it from Angie.
That's me. Thanks for joining us today. See you next time.